Assalamu alaikum dear friends, you are watching Study with Sheraz, and in today's lecture we are going to discuss about the polarization and the polarizing power of the ions. First of all, we have to understand this picture, this concept, then we would move toward the definition of the polarization and the other factors. So first of all, here it is cation and it's anion. Whenever a cation and anion interact with each other, they approach each other, the cation attracts the electronic load of the anion and the anion attracts the electronic load of the cation. As a result of this attraction, the cation draws the electron density of the anion towards itself. So this is basically the polarization. So you people here can watch that here the anion was a spherical. So spherical is basically showing the uniform electron density or uniform charge distribution around the nucleus of the anion, and here the distribution of the charge or the electron density is not uniform. If the nucleus of the anion is located here, the electron density has shifted toward the cation. So this shifting of electron density towards the cation is basically known as the polarization. So what is the definition of polarization? It's the deformation of electronic load of the anion caused by the cation. So polarization is caused by cation, and this is a phenomenon that is operating on the anion. So keep in mind that polarization is occurring on the anion, but it's caused by the cation. Next important point is the polarizability. So ease with which electronic load of an anion can be distorted. So polarizability is basically the tendency of an anion to be polarized, to be distorted, caused by the attraction of the cation, or the ease of anion to be polarized. And the next important point is the polarizing power. So polarizability was linked with the anion and polarizing power is linked with the cation. So it's the ability of a cation to cause the polarization of anion. So basically keep in mind that polarizability is linked with the anion, whereas polarizing power is linked with the cation, and it's the power of a cation, ability of a cation to polarize the anion. The question here arises that up till now we have only talked about the polarization or the distortion of electronic load of the anion caused by the cation. So is it that a cation is not polarized, or is it the anion that is not attracting the electronic load of the cation? The answer is no. The anion is also attracting the cation or the electronic load of the cation, but as you people know that a cation is smaller than parent atom. When an atom is converted into the cation, the size of the cation is very much smaller as compared to that of the neutral atom. Whereas if we talk about the anion, the size of anion is greater than that of the parent atom. So in case of cation, the hold of nucleus on the electronic load is much greater or much stronger as compared to that of anion, where the hold of nucleus is much weaker as compared to that of neutral atom. We have a separate video in which we explain that why the size of cation is smaller than the size of atom, why the size of anion is greater than that of the parent atom. So that video is present at the end of the screen, so you must watch that video to get the concept clear. So in case of a cation, the hold of nucleus is much stronger. So whenever anion attracts the electrons or the electron density of the cation, it's much difficult for a large anion to polarize the electronic load of the cation. So the possibility or the tendency of the electronic load of the cation to be distorted is much lesser as compared to that of the anion. So the answer to this question is that cation is not polarized because of the strong nuclear force on the smaller electronic load of the cation. The next lecture would be on the Fajon's rule. You must watch that lecture to understand the factors affecting the polarizability and the polarizing power. If you have any question related to this video, you can post your question in the comment section. So we will meet in the next video. Till then, Allah Hafiz.